Now this is difficult because there should be bulky group and there should be bulky group. Due to this, water approaching is difficult. Okay. Trans effect, the tendency of a ligand coded to platinum to plus in a square planar complex to direct the incoming ligand to occupy a position trans to it is called trans effect, and such ligand which directs the incoming ligand to occupy position trans to it is called trans-directed ligand. So there should be always tendency, that is the ligand which having trans effect initiate the other ligand which approach to it must be placed in the trans to the this specific ligand. Means if Cl minus trans effect greater than ammonia, so Cl minus this initiate, that is incoming equable approach trans to the Cl minus. Okay. So trans to the Cl minus ammonia placed. Okay. Again, Cl minus having trans effect more than ammonia. So this Cl minus approach the other ammonia, that should be trans to it. Okay. So by this way get cis platin. Again, platinum NH3 whole for 2 plus, there should be all are ammonia. So one Cl can be replaced by other ammonia by simply substitution reaction. Okay. So now the problem is the incoming second chlorine attached on what side? Okay. As Cl minus having more trans effect than ammonia, so the incoming equipile will be attached to the trans to the first Cl minus. Okay. So this Cl minus come the trans to previous Cl minus. By this way we get trans platin. Okay. Now the trans effect COCN minus C2H4 PR3H minus methyl CH3 minus, then TU, then C6H5 minus phenyl NO2 nitro I minus HCN Br minus Cl minus pyridine ammonia water OH minus and F minus. Okay. That is high trans effect to low trans effect. Trans effect decreases. As COCN minus C2H4 they are pi acceptor ligand, so they having high trans effect because when their pi acceptance is high, they produce stronger metal ligand bond. So due to this, they always make their trans ligand loosely bounded to the metal. Okay. Like for example, they produce more attraction to the metal, so they make also less attraction to the trans ligand with metal. Okay. Then PR3H minus CH3 minus, because H minus CH3 minus they are good sigma donor, so they produce more good or more stronger bond with platinum 2 plus. Okay. So they also make the trans ligand loosely bounded to the metal. Okay. Now fluorine, chlorine, bromine, iodine. From fluorine to iodine, size of the ligand increases. As fluorine, chlorine, bromine, iodine in the group, they are present top to down. So extra shells are added. So on the case, their size also increases. Okay. Electronegativity decreases. As there are extra shells added, their size increases. So their charge density, that should be charge by size ratio, that should be decreases. So due to this, their electronegativity that also decreases. Okay. As their charge decreases, so they are lessly attract electrons towards itself. Okay. And polarizability increases, because polarizability increases because the charge density decreases and their size is increases. They are more diffused in nature when they go top to down. So on that case, their polarizability increases. Okay. And due to the three reasons, that is size, electronegativity and polarizability, the trans effect also increases. Okay. Now PR3, then NO, then CO, then NO positive. That is from left to right. When we go, pi excitability increases. When pi excitability increases, they are produce metal ligand. They are produce metal ligand double bond character. So that's why its transposition ligand having low attraction force towards metal, and that's why this trans ligand can be easily leave. And so for Pr3NO, CO and NO positive, their trans effect is more higher, and they in their transposition can be able to perform substitution reaction more easily. Okay. So these are all a same type of ligands are there. When there is L ligand is there, okay, so L is more good. Suppose that is L is more good, that is diminish positive charge on platinum 2 towards X trans to L. Okay, L is more good, so there should be del negative character, platinum having more del positive character, so there is good attraction force. Okay, so there, in that case, attraction force decreases. In that case, attraction force decreases. Attraction of X to trans to L towards platinum 2 is decreased or diminished. And as we know, there should be platinum in that side produce del positive, so in that side del negative is produced, and due to del negative and negative charge of X produce repulsion. Okay, due to negative charge of platinum and negative electron density of X produce electronic repulsion, and due to this platinum L bond stronger but platinum X bond are longer and weaker. Platinum L bond become shorter and stronger bond, but platinum X bond become longer and weaker bond. Okay. Suppose in any three friends are there, two friends are closely closed mentality and they are having good friendship to each other. Okay. So on that case, obviously the third friend having loose friendship with the two. Okay, similar things will be there. Okay, when in three friends, two friends are very close to each other in friendship, so the other friend will have loosely having friendship with the first two. Okay, similar thing will be there. As in first case, symmetrical distribution of electron can be occur because all are X. Okay, when L is introduced, on that case if L having more negative character and more profound effect with metal, so there should be metal ligand bond is more stronger, and as also platinum positive can be more the partial positive charge of platinum more effective to bind with negative charge density of ligand. So in the opposite of side of platinum 2 plus, there are some negative charges introduced, and this negative charge make repulsion, electron repulsion with the negative charge of X ligand. Okay, due to this electron repulsion, platinum X bond become longer and weaker. Okay. Similar things can be there. If three friends are there, there should be suppose first there should be two friends, Ram and Shyam. They are having close friendship with each other. Now Jodu come and they Jodu make good friendship with Ram but does not like Shyam. Okay. Suppose Ram and Shyam is good friend from childhood. Now in HS Jodu come and Jodu make good friendship with Ram, but Jodu does not like Shyam. So Jodu when make friendship with Ram and constant telling against of Shyam, there in some situation come where Jodu and the bond or the friendship between Jodu and Ram will be stronger and unbreakable. But the friendship between Ram and Shyam is weaker and breakable. Okay, similar things can be occurred in the complex formation. There should be first all are X. There must be no problem. There must be no unsymmetry. But when ligand approach, there should be ligand having more tendency to bind with platinum 2 plus. So platinum and ligand make more stronger bond on that case the platinum X bond become longer and weaker. And that's why what is the consequence? That X leave, and in the place of X, Y or any incoming group that should be attached with it. Okay. Suppose Ram and Sham like friendship, there should be Jodu is a third person. He make more friendship with Ram and constant telling against about Sham. So what happened? Sham get angry with Ram and he leave. Okay. Similar thing can be occur. Okay. Okay. Now the transipate can be explained. So what I explained, that is summary, that is steric, from first to last I can explain all of the things. That is, definition of substitution reaction is nothing but ligand replaced one another. Okay. Already in complex some ligands are there and they are arranged by the around the metal, one other incoming ligand approach and one ligand which are remain in the attached with the metal, that should be leave, and that is only the replacement of one ligand to the other. That should be termed as substitution reaction. Okay. In organic substitution reaction, you can study, that is about SN1, SN2 type reaction. In SN1 reaction, before nucleophile approach, there intermediate carbocation is produced, and then after nucleophile attach with it. So we get overall racemic mixture. In SN2 reaction, there should be first nucleophile attack from backside, so we get inverted product. Similar things almost there, but there should be no SN1, SN2 reactions are not occur. In inorganic chemistry, in complex formation, generally dissociative and associative reactions are occur. So there must be unimolecular nucleophilic substitution reaction are SN1 mechanism. Bimolecular nucleophilic substitution reaction are termed as SN2 reaction. Okay. Unimolecular because depends upon only one species concentration, and bimolecular means depends upon two molecules, two species concentration. Okay. But if we observe in inorganic chemistry, we have to consider dissociative and associative mechanism. In associative mechanism, due to nucleophile attached with the initial complex, so the reaction proceed. So for that reason, for associative mechanism, depends upon the two concentration. One is initial concentration, other is nucleophile concentration. Okay. And in dissociative, there should be bond breaking is more important. There should be first leaving group leave, and then after intermediate formation, then nucleophile attached with it. So that should be the rate is depend on only initial complex concentration. Okay. So by this analogy, we can use dissociative mechanism as unimolecular nucleophilic substitution reaction and associative as bimolecular nucleophilic substitution reaction. Okay. There is also interchange mechanism, because interchange means when bond dissociation and bond formation can be taking place simultaneously. That is, if IA, we can say interchange in IA and ID. When association is more important, that should be termed as IA, associative interchange, and when dissociation is more important in the step, so we can say ID or dissociative interchange. Now we consider for unimolecular nucleophilic substitution reaction, or we can say dissociative mechanism, that should be only depends upon initial complex concentration, and because there should be first leaving group leave and produce lesser that is low cohesion number, that is if cohesion number 6 in initial complex, we get cohesion number 5 as intermediate, and then again nucleophile approach and we again get cohesion number 6 complex. Okay. And bimolecular nucleophilic substitution, there should be nucleophile concentration and initial complex concentration, both are used, both are important. So first nucleophile attach with it, and we get, if initial complex is cohesion number 4, we get cohesion number greater than initial complex, that should be cohesion number 5. Okay. Again we get cohesion number 4. Okay. Now there should be pathway are used. That is, for square planar complexes, first initial complex nucleophile attached with it and produce square pyramidal. Then square pyramidal transform into TPP shape geometry, and then TPP shape geometry convert into square pyramidal. Again it get square planar complex. Okay. Next one, there are some energy diagram. In first one, that is My bond formation and Mx bond formation, both are equally important. In second case, My bond formation is more important and redetermining step or RDS step. And in third one, there should be Mx bond dissociation is the determining step. By this three analogy, we get three defined curve. Okay. Square planar complexes having striking features. First one, they are tetra-coordinate, coordination number 4, and that's why they are coordinately unsaturated. They are having vacant site above and below of the square planar complexes. Second one, they are 60 electron in valential, so they are electronically unsaturated. Okay, and they have vacant pz orbital that should be perpendicular to the xy plane. So incoming ecopile having no static hindrance when they approach. Okay. Now square planar complexes having En value less than the noble gas. Okay. If nickel Cn whole 4 2 minus effective atomic number 34, and that is octahedral complex nickel NH3 whole 6 2 plus En value that is 38. So nickel Cn whole 4 2 minus having effective atomic number value that should be less than noble gas configurations. Okay. All these features can be give the idea that square planar complexes always maintain associative mechanism due to coordinately unsaturated, due to electronically unsaturated, and having vacant pz orbital. Okay. Now platinum 2 plus is most used because platinum 2 plus always produce square planar complexes. Platinum 2 plus complexes are easy to study, and platinum 2 plus complexes, square planar complexes are easily synthesized. Okay. The reaction can be carried out water or solvent pathway, or it can be carried out in nucleophile pathway. Okay. In nucleophile pathway, it depends upon both of concentration of nucleophile and concentration of initial complex. If depend on solvent pathway, there must be solvent in excess, so does not depend on solvent concentration, so only depend on initial complex concentration. Okay. In solvent control pathway, there should be 2 DPP intermediate can be produced, and substitution taken place 2 times, because first one water attached with it and produce TPP shape intermediate, then it produce square planar complex, again nucleophile approach to it and water emit or water release, and then again TPP shape intermediate produce, so we get square planar complexes. Okay, so 2 times substitution can be occur. So there should be 2 pathway. We can say in solvent control pathway that should be pseudo first order, because solvent is excess, so does not depend on solvent concentration. And interligand pathway is first order because depend on nucleophile concentration or ligand concentration. We can say that then common with taking common platinum A3X, that is initial complex concentration, we can get that is K1 plus K2 concentration of Y. If solvent present in excess, we can say that is solvent control pathway is only first order reaction. So K1 is first order rate constant for solvent control pathway. As in nucleophile pathway, there should be depend upon both of nucleophile concentration and initial complex concentration. So that's why K2 equal to second order rate constant for entering ligand control reaction. Okay. But if nucleophile concentration is larger and excess, so on that case concentration of nucleophile also taken as constant. So on that case we can say K observation platinum A3X. I had K observation equal to K1 plus K2 concentration of Y. And K observation equal to observed rate constant or pseudo first order rate constant. Okay. Now if we observe K observation as equal to Y and equal to Mx plus C, so we get M equal to K2 value, M equal to K2 value, that is slope, and C equal to K1 intercept, Y equal to C plus Mx. You can say that is Y as K observation, concentration of Y is X, so we get slope M equal to K2 and C equal to K1. Okay. Now some useful example, that is platinum Cl4 minus, platinum NH3 whole 3 Cl3 minus, and so on. That should be termed only this, that is when positive charge increases in platinum, so platinum Cl dissociation is much more difficult and formation of platinum OH2 becomes more easy. Okay. Next one, stereospecificity. That is the complex, if having cis orientation, it always gives cis orientation as a product. And also if initially having trans orientation, it always gives trans orientation product. That there should be 2A as cis, we get 2A as cis. There 2A as trans, we get also 2A as trans. Okay, so that should be stereospecific. Now chelate effect, that is metal makes more stable complex with ethylene diamine rather than ammonia, because ethylene diamine produce ring structure, that's why. Okay, ring gets more stable. Okay, now we also consider HSP principle, hard soft interaction. That is hard always prefer hard, soft always prefer soft. So platinum 2 plus is softer, so it always prefer iodine ion, then bromide, then chloride. Okay. Okay, next one, approach of water is difficult because there should be platinum A3 are bulkier, so that's why water when go and Cl must be removed. This process is very much difficult due to steric hindrance. Okay, trans effect is nothing but, that is the ligand always initiate the incoming nucleophile approach to trans to it. Okay, and there should be some application of trans effect. As we know, trans effect of Cl is more than ammonia, so always Cl always directs the incoming nucleophile trans to it. Okay, by this analogy we get cisplatin and transplatin also. Last one, that is the high trans effect to low trans effect series are there. As we know, PR3 NO CO NO positive make more pi acceptor, they are pi acceptor ligand, so they produce more stronger metal ligand bond, so they produce that trans ligand loosely bounded. Okay, and also fluorine, chlorine, bromine, iodine, there should be size of ligand increases, electronegativity decreases, polarizability increases. By these three reasons, the overall trans effect that should be increases. Okay, and there the picture, that is the symmetrical distribution of electrons around the platinum, then ligand approach it, that is other types of L ligands are there, so L make more stable bond with metal ligand bond, so that's why platinum X bond longer and weaker bond, and platinum L bond becomes shorter and stronger bond, and that's why the consequence is X is always tendency to show lip, and Y, that is incoming nucleophile attached with the place of X. Okay, this is termed as trans effect of the whole process.